Hello everyone, I am Professor Ken Maktore. In this today's session, we are going to study the follower motion, which is the uniform acceleration retardation. There are the total four types of follower motion. One is the uniform velocity, second simple harmonic motion, uniform acceleration retardation, and last one is the circular motion. Today, we are going to study one of the important follower motion, which is the uniform acceleration retardation. The session objective of this today's session student to teach student how to draw the displacement diagram for the uniform acceleration and the retardation, and what student will do after studying this, they can design the cam profile using the uniform acceleration retardation for a particular application. Now these are the some notations. S, which is the stroke length, omega is the angular velocity, theta is the cam angle, theta O is the outstroke angle, theta do, which is the dwell after of stroke, theta r is the return stroke, and theta dr is the dwell after return stroke. This is the diagram, which is the displacement diagram. This is the velocity diagram, and this is the acceleration diagram. Now this is the equation for the displacement of the follower for the uniform acceleration retardation. If we differentiate this equation, we will find that v is equal to 4s omega into theta upon theta o square. If we differentiate this, that theta, the derivative of theta, which is the omega, and again if we differentiate this equation, again this theta becomes the, again this, okay, this is of, sorry, this is the equation of Vmax, which is the maximum velocity. When we get the maximum velocity, when that theta is equal to theta o by 2, when that theta is equal to theta o by 2, at which we will get the maximum velocity. Again we move to the, okay, theta is equal to theta by 2. Now if we differentiate this equation, we'll find the acceleration, which is of 4s, that theta becomes the derivative of that theta becomes the omega, that means omega which becomes the omega square. This is the final expression for the acceleration. Again there is no any term to differentiate this, that means here we will get the constant acceleration. That's why this method is called as the uniform acceleration retardation. In this uniform acceleration retardation, this first portion, this portion which is the uniform acceleration, and this during return stroke, this portion which is the uniform, that means retardation. Now in this case, that we will get the maximum acceleration, we will get the maximum velocity, theta is equal to theta o by 2. Okay, actually there are some modification in this diagram. Actually it's my mistake. Actually during rise, this is the uniform acceleration up to this portion, when that theta o by 2, and during retardation this portion should be like this, which is the retardation. In the single curve, this is the uniform acceleration and this is the uniform retardation, but during return stroke, this is of uniform, that means this slope which is the negative slope, that's why this is the uniform retardation. When theta r by 2, again that curve which is like this. Again during return stroke, first of all you will find the uniform retardation and then you will find the uniform acceleration. That's why it is called as the uniform acceleration retardation curve. Now we'll study how to draw that displacement diagram for the uniform acceleration and retardation. First of all, you have to draw one horizontal line which refers the cam angle of 360 degrees. Next, draw one vertical line whose length is equal to stroke length, which is of s. This is the cam angle. Next, divide that cam angle into the four parts. One is the theta o, second one is the theta do, third one is theta r, and next one is the theta dr. Okay, before that, take these distances is equal to 60 mm. This distance is of 60 mm, this is of 20 mm, this is of 60 mm again, and this is of 40 mm. That means total distance is of 180 mm. Next, theta O that we already mentioned. Again, in this case, this is any one angle, which of 120 degrees, 30 degrees, 90 degrees, and the 120 degrees. Okay. Now divide this theta O and the theta R into the 6 equal parts. That means one part is equal to 10 mm. Just like this, you have to divide and you have to give the notations 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 should be your last number. And that vertical length is equal to stroke length. Next, what we have to do, we have to just construct the middle portion. That means this is the first part, this is the second part, this is the third part, this is the fourth part, fifth part, and sixth part. That means you have to construct the middle portion. That means line number 3. That we have to divide. That you have to divide it into the 6 equal parts. That I have divided into 6 equal parts. Now we have to give the notation 1a, 2b, 3c, 4d, 5e, and the 6f. Now you have to join. Now you have to join from 0 to 1. Okay, first of all you have to draw the diagonal line. Next you have to join. Next you have to join 0 to 1. Next 0 to 2 and 0 to 3. When 0 to 1 line intersects that vertical line at one point, that point is A. This line, inclined line, which intersects vertical line 3 at point B. Again, this line intersect line number 3 at point C. In the same fashion, you need to mark. But during next half part, you have to draw the lines from this. Next, you have to join 0 to 4. That 4 line intersect this vertical line 4 at point D. Next, this line intersects 5 at point E, and this is the point F. Now you have to give the notations A, B, C, D, E, F, and you have to draw the smooth curve. This curve which is called as the uniform acceleration retardation curve, in which half part is for the acceleration and next half part is for the retardation. Next, this is the FG at which there is no any displacement of the follower. That's why this is the 12. Next, again during return also you have to follow the same, but you have to start from the top. Here you have to start from the bottom. Now here you have to start from the top. Again you have to consider the middle line, that you have to divide into the 6 equal parts, and you have to give the names, notations 8H, 9I, 10J, 11K, and 12L. Now from this portion, from G, you have to draw, first of all again you have to draw the diagonal line, and from this portion you have to draw one line to connect that 8. This 8 and this 8 are intersects at common point. Next 9, this 9 and this 9 are intersects at common point. This is the diagonal line, that means this is the point. Again from this portion, for the middle half you have to consider the diagonal point. Now this 11 and this 11 which intersects at common point, and this 12 and this 12 which are intersects at common point. You will get these points. You have to give the notations, and you have to draw the profile. And this is the total cam profile. This is the total displacement diagram for the uniform acceleration and retardation. In this way, we have learned this how to draw this displacement diagram by using the uniform acceleration retardation motion method. Again, we have started with its mathematical modeling, in which we have studied that displacement equation for the displacement diagram. If we have differentiate it, we will get the velocity. Next, again if we differentiate with the time, we will get the acceleration. Again in this case also, in the acceleration there is a sudden rise, and if you differentiate that acceleration at that sudden rise in the acceleration at the start and at the end, which when we differentiate it, it becomes the infinity. That means again in the equation of the jerk, you'll find the sudden jerk, and again that's why this that means profile which is not applicable for the high speed application. With this I will finish over here. Thank you for your patience listening. Thank you.